So we're going to take a look at our quiz for 5.2 and 5.3. Our first question, we want to identify the polynomial as monomial, binomial, trinomial, or none of those, and also give the degree. So for number 1, we have fourth degree polynomial, because 4 is the highest degree of any single term, and there's 3 of those, so this is a fourth degree trinomial. For number 2, there's only the 2 terms, so that's a binomial. 7th degree is the highest degree that we have, so that's a 7th degree binomial. For number 3, looking at adding these together, again, you have some choices if you would like to set that up horizontally or vertically. I think I'm just going to go with horizontal in this case. I like to kind of arrange it highest to lowest degree. That also gets my like terms together. So I would have 3x to the 9th. So 3x to the 9th plus 9x to the 9th. That takes care of my x to the 9ths. I've got a minus 2x to the 8th here and a minus 5x to the 8th there. Let's see, I have a plus 9x to the 7th and minus 5x to the 7th. And beyond that, it looks like I have a minus 2 and a plus 9. And there we go. So starting with my highest degrees, combining those together, 3x to the 9th and 9x to the 9th, that's a total of 12x to the 9th. My x to the 8ths are both negative, so minus 7x to the 8th. My x to the 7th, I have a 9 minus a 5, so that's a plus 4x to the 7th. And then a minus 2 and a plus 9, so that would be a plus 7. For number 4, we're looking at subtracting. So I need to switch the signs on each of the terms in this polynomial. Again, I like to start with the highest degree, so I have a 3x to the 5th to start with. And I have a minus 7x to the 5th, so minus, that's 7x to the 5th. My next highest degree is x to the 4th, so I've got a minus 4x to the 4th. And then here I've got minus a minus, so that ends up being plus 7x to the 4th. After that, I'd be looking for my x cubes. I have a 7x cubed here and a minus 3x cubed. So 7x cubed plus 3x cubed. And then I've got my constant minus 8 here, minus 3. Ooh, but be careful, again, it's minus a minus 3, so it's going to be minus 8 plus 3. And then I just go about combining my like terms. The 3x to the 5th minus the 7x to the 5th, so that would end up being minus 4x to the 5th. Minus 4x to the 4th plus 7x to the 4th would be plus 3x to the 4th. The x cubes are both positive, so plus 10x cubed. Minus 8 plus 3, so minus 5. And again, that's already in descending order of powers. For number 5, they just want me to find f of 7. So they give me that function f of x. So to find f of 7, I just replace the x with 7. So I get negative 21 plus 3, so we end up with a negative 18. So that is what f of 7 equals, is negative 18. For number 6, they want me to find f of negative 3. Just going to be very careful when using a negative here, especially when squaring a negative. Remember, that will end up being positive. So again, doing a little bit at a time here. Squaring the negative 3 gives me a positive 9. The 2 times the negative 3 would be a negative 6, so I'll go minus 6 and then minus the 8. So we get negative 27 minus 6 minus 8. So negative 33 minus 8. And so from there we would be looking at f of negative 3 would equal negative 41. So there we go. That's what that ends up with. So for number 7, they give us this polynomial to model the approximate total earnings of a company in millions of dollars. X equals 0 corresponds to 1996. X equals 1 corresponds to 1997. They want us to use the model for the earnings in 2000. So 2000 minus 1996, which is year 0, equals 4. So x equals 4 in 2000. So what we do is we'll just replace all of the x's in our model with 4. And again, with these numbers, we're going to let the calculator do most of the work. But again, replacing those with 4, and we should be coming up with $2.1756. So it's $2.1756 million. So we could either write that out, or you just put a comma there. That'd be $2,175,600. And again, nice to actually answer the question. But again, 2.1756 would be fine as well. Now they do say around to the nearest hundredth, and that would be fine. I guess in that case it would be $2.176 million. Looking at number 8, they give us those functions. They just want us to find f plus g of x. When I'm looking for f plus g of x, again, that's really just f of x plus g of x. So I'm really just adding those two polynomials together. So 5x minus 4 plus negative 8x plus 6. So I can combine my x's. That would be a negative 3x. Combine my numbers, negative 4 and 6, so a plus 2. So that's what we get for f plus g of x. For number 9, same kind of idea. We get our f of x and our g of x, but now we're looking for f minus g of x. So again, that's really f of x minus g of x. So I take my function for f of x, the 4x minus 3, and I subtract from that the negative 8x plus 8. So 4x, and this would really be plus 8x, and a minus 3 minus 8. So we end up with 12x minus 11. So that's what f minus g of x equals. For number 10, we're looking for f minus g of 3. Again, we get our functions f of x and g of x. One way to do this is to find f of 3 minus g of 3. So in order to do that, I would have to find first f of 3. Well, that would be just 3 squared minus 6. So 9 minus 6, or 3. So I know f of 3 is 3. I need to take g of 3 away from that. So g of 3 would be 3 times 3 plus 5. So 9 plus 5. So that's 14. So g of 3 is 14. And I'm finding f of 3 minus g of 3. So that ends up being 3 minus 14. So negative 11. So that's what f minus g of 3 equals. Another way you could do that is you could find f minus g of x, which would be x squared minus 3x minus 11. Replace the x with 3, and it would give you the same answer of 13. For number 11, we're actually evaluating a composition of functions. Now remember, our composition is not an operation like adding, subtracting, multiplying, or dividing. We're actually inputting one function into another. A different way to write g of f of 6 is to write it like this, where we have g of f of 6. So I can see I'm really looking for f of 6. Also, to find f of 6, I can replace the x in here with 6, so 6 squared plus 2, so 36 plus 2, so f of 6 is 38. Well, if f of 6 is 38, then this would be g of 38, and so to find g of 38, I just plug the 38 into function g. 4 times 38 gives me 152. Add the 5, I get 157. So that's really what g of f of 6 equals, is 157. Our next question, number 12, asks for f of g of x. So give me those two functions. And again, just a different way of writing that. Looks like this. Again, I can't really evaluate g of x, but I do know g of x is 4x minus 1. So I'm trying to figure out f of 4x minus 1. So in my f of x function, I take and replace the x with 4x minus 1. I have to distribute my 4, so I get 16x minus 4. Add the 11 to the minus 4, so 16x plus 7. So that's what f of g of x equals, is 16x plus 7. For number 13, we're still looking for f of g of x. So g of x is x squared minus 5, so I'm looking for f of x squared minus 5. So I replace my x in my function f with x squared minus 5, so 3 x squared minus 5 plus 2. I distribute my 3, I get 3x squared minus 15 plus 2, and so I end up with f of g of x equals 3x squared minus 13. So that's what we're looking at for number 13. After that, we get into our final two graphing questions. So for number 14, we're looking at f of x equals x squared minus 2. Really what we're looking for here is to plot enough points to get an idea of what the graph looks like for a second degree polynomial function, which we call quadratic. The shape of the graph will be a parabola. So if I make a table of values for that, then I can find the x and y ordered pairs that I'll plot to come up with my graph. Now feel free to use the graphing calculator to help you with that table. Again, it's just a quick way of figuring out those values. Although in this case all I'm doing really is squaring the negative 2 for this first value here, so I would get 4 minus 2, which would give me 2. So negative 2, 2 would be a point on my graph. So it would be about here. The negative 1, I would square that and get 1 minus 2 would give me negative 1. So negative 1, negative 1. 0 would give me negative 2. 1 would give me negative 1. And 2 gives me 2 as well. So those are my points. Again, draw a nice curve through those points, and again we can expect the shape of the graph to be a parabola. And for our final question, number 15, we're graphing a cubic polynomial function. Again, if we just look at finding some values right around 0, it should work out pretty well. Again, also feel free to use the graphing calculator to look at the table of values and a picture of the graph to help out with that. When I plug in a negative 2 for x, I end up getting actually a 1 for y. Negative 1 gives me 5, 0 gives me 3, 1 gives me 1, and 2 gives me 5. Again, feel free to look at the graph to see where those curves happen, but negative 2, 1 is a point, negative 1 goes all the way up to 5, 0 gives me 3, 1 is 1, and 2 is up at 5 again. So based on the window that we're looking at, we can see pretty well what's happening there. So from here we just draw a curve through our points. Again, using the graphing calculator to help us see where those curves happen and what the end behavior looks like. So again, looking for those specific points to be plotted, a nice curve drawn through there. So thanks for watching, and hopefully it helped.